This lesson is on simplifying expressions. We're going to first talk about the parts of an expression. Keywords. We have numbers that are in front of the variables. So this 5 and a 3, those are called coefficients because they are the number that is with the variable. So 5 and 3, that's our coefficient. In math, a letter is called a variable. So we have two variables, but they are the same variable in x. When you have a number without a variable, that is called a constant term. The reason why it's constant is because it's going to stay at 5 no matter what my variable changes to. This 2 is called an exponent. And we have two addition signs in the problem. The two addition sign separates my expression into 3 terms. So terms are separated by addition or subtraction. If they're being multiplied, like the 5x squared and the 3x, they're not separate terms, it's just one singular term. When we're combining expressions or simplifying expressions, we're going to look for our like terms. Like terms have to be the same variable and the same exponent. If we have like terms, we can combine them. Here we have an example of a like term. We have negative 3x squared and 7x squared. They have the same variable, same exponent. So I can combine those to give me 4x squared. Another set of like terms is 8x and negative x. When there's no number with the variable, we pretend there's an imaginary 1 there. So we have 8x and negative 1x. That combines to give us 7x. Another set of like terms is 6xy and yx. They don't look like terms, but multiplication is commutative. You can reverse the order. So yx is the same thing as xy. That's why it's always best to write multiple variables in alphabetical order to clearly see if they're like terms. We have an imaginary 1 there, so we combine these, we would have 7xy. And those are our only set of like terms. The 7x squared y and negative 9y squared, negative 9xy squared, are not like terms, even though they have the same variable. Here, the exponent of the 2 is with the x, but in this term, the exponent of 2 is with the y. So that's why they are not like terms, so I cannot combine them. Simplify the expression. Simplify the expression just means to combine the like terms. So I'm going to go through my list and see what I have for like terms. I have negative 6, a positive 7, and a negative 9. Notice how I took the sign with my numbers as well too. So I would just combine them. Negative 6 plus 7 is 1, and then minus 9 is negative 8. I look for my other like terms, negative 6f and negative 3f. Those are like terms because they have the same variable, the same exponent. So I can combine them to give me negative 9f. It's always best to write your expression with the variable term coming first. So a better answer would be negative 9f minus 8. This would be our answer in standard form. Simplify the expression. Again, look for like terms. Negative 3.7 and positive 11.1. They are like terms, so when I combine those, I have a positive 7.4. positive 5g and negative 10g are like terms, and they combine to give us negative 5g. Plus 4k does not have any like terms, which is okay, so all we're going to do is just bring it down. Now this is a correct expression, but again, we want it multiple variables in alphabetical order. So we'd have negative 5g, a positive 4k, and a positive 7.4. This would be a better answer written with my variables in alphabetical order. Simplify the expression. 59.95 m, positive 7.95 m, and positive 9.49 m. Again, take the sign with the term when combining them. So 59.95 plus 7.99 is 67.94 plus 9.49 is 77.39 m. And then we have a negative 30, even though it's a minus sign, it goes with the 30. Negative 30 plus 45 is a positive 15. And my variable term comes first, so my answer is correct, written in standard form. Evaluate the expression for x equals 3 and y equals negative 2. Evaluating the expression means we're going to replace the variable with the given number that it relates to. So we have 3 times x, so instead of 3 times x, we're going to have 3 times 3, plus, instead of 4 times y, it's going to be 4 times negative 2, and then the minus 2 comes down. Notice how this negative 2 was our constant term, and it's staying a negative 2. It's remaining constant. 3 times 3 is 9, 4 times negative 2 is negative 8, and the minus 2 comes down. 9 minus 8 is 1. Bring down the minus 2 again. 1 minus 2 is negative 1. So when we evaluate this expression, we get our answer of negative 1.